Day 343 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2970. Count the number of incremovable subarrays 1. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero-indexed array of positive integers nums. A subarray of nums is called incremovable if the nums become strictly increasing on removing the subarray. For example, the subarray 3, 4 is an incremovable subarray of 5, 3, 4, 6, and 7 because removing this subarray changes the array 5, 3, 4, 6, and 7 to 5, 6, and 7, which is strictly increasing. Return the total number of incremovable subarrays of nums. Note that an empty array is considered strictly increasing. A subarray is a contiguous, non-empty sequence of elements within an array. All right, y'all, I know that seems like a lot to take in, so let's go ahead and take a look at these examples just to make sure that we are solving this problem correctly. So in example 1, we have the input nums equals an array of integers 1, 2, 3, and 4. Output is 10. Explanation says the 10 incremovable subarrays are 1, 2, 3, and 4, 1 and 2, an array 1 and 2, an array 2 and 3, an array of 3 and 4, an array of 1, 2, and 3, an array of 2, 3, and 4, and an array of 1, 2, 3, and 4 because on removing any of these subarray nums becomes strictly increasing. Note that you cannot select an empty subarray. All right, y'all, so let's go ahead and break this example down one step further so we can understand what it is that they're doing. So we want to count how many subarrays we can create that when we remove these subarrays, the remaining elements in the input array is strictly increasing. So as you can see, if we remove 1, say we remove this 1, or let's just copy and paste this so it could be a more visual representation. But say we remove this 1, right? Let's start with 1. We remove this 1. Boom. This array is still strictly increasing. So 1 goes into this incremovable subarray count. So now let's remove this 2. The next element is 2, right? 2. So if we remove this 2, it's still increasing, right? The remaining array is still increasing. Same thing if we remove the 3. If we remove the 3, subarray is still increasing. Boom. Same thing if we remove the 4. If we remove the 4, subarray is still increasing. Boom. If we remove the 1, 2, we could remove this 1, 2, subarray is still increasing. We could remove this 2 and 3, subarray is still increasing. You know what I'm saying? We remove this 3 and 4, boom. Excuse me, y'all. The array is still increasing, and so on and so on. So y'all get the point of how this works, right? So if we remove all these numbers, the number will still be increasing. And it also says at the end, say we remove all 4, right? If we remove all 4 of them, it says right here, a subarray is a contiguous not right here. It says note that an empty array is considered strictly increasing. So if we remove all 4 and we're left with the empty array, it is still strictly increasing. So that's what they want us to do. So let's just go ahead and take a look at the rest of these examples just to make sure we understand what's going on in case they try to throw some trick questions our way. Also, it's important to note that we're not returning these subarrays themselves, right? We're returning the count of them. There's 10, so we're returning 10 because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 subarrays or 10 incremovable subarrays that we can create, and that's why we're returning the count. We're not returning the actual subarrays. Now let's go ahead and take a look at example 2. So in example 2, input nums equals an array of integers 6, 5, 7, and 8. This time the output is 7. That means that there are 7 incremovable subarrays that can be created, and they're listed here, right? Similar, same principles as what I just showed you with the example 1. If we remove this 5, it'd be 6, 7, 8, which is increasing. Same thing, if we remove this 6, it'd be 5, 7, 8, which is still strictly increasing. And that pattern continues with all of these subarrays. And there are 7 of them in total, so we return 7. Now let's look at example 3 where they might try to throw some trick questions our way, right? So in example 3, we have the input nums equals an array of integers 8, 7, 6, and 6. This time the output is 3. It says the incremovable subarrays are 876, 766, and 8766. Note that 8, 7 is not an incremovable subarray because after removing 8 and 7, nums become 6, 6, which is sorted in ascending order, but not strictly increasing. So we cannot count 8 and 7 as an incremovable subarray because we'll be left with 6, 6. However, 6, 6 is not increasing. It's not decreasing or increasing, but we want it to be strictly increasing, which means if it's not increasing, then it doesn't count, and so 6, 6 does not count. So now that we understand the question, y'all, let's get into the fun part, actual solution. Solution is not that difficult either. I know the question wasn't that difficult to understand, but you never know. Maybe it was for some people, so we got to go through it just in case. Now let's get into this solution. Now, the first thing we need to do is we need to create a counter to track the number of valid incremovable subarrays. So in order to do that, we could just declare a variable. We could call it ands, and we could set that equal to 0. It's going to keep count for us though. Now we need to loop through all the possible indices of I of the subarray to remove. So we're going to say for I in 0 ... less than nums count. We're going to open up the brackets. Now we need to loop through all the possibles starting from indices j of the subarray to remove. So we're going to say for j in 0 ... 3 dots up to I. Then we're going to open up the brackets. Now we need to create a flag which is going to indicate whether the array after removal is strictly increasing. So we could just declare a variable, call it flag, and we can set that equal to true to start. Boom. And now we need something to store the last value in the filtered array, and we'll just initialize it to -1 to start. So we can say var last equals -1. Now we need to loop through the array, skipping the range of j through I and removing the subarrays. So for that, we come right here and we say for k in 0 ... up to sign nums count, where k is less than j, or vertical line, k is greater than I. Then we're going to open up the brackets, and we're going to say if nums square bracket k is less than or equal to last, we're going to open up the brackets. And if the current value is not strictly greater than the previous one, then the array is not strictly increasing. So we could say flag equals false. It's going to say false, and then we could break. We could just say break. Then we come right here, we say else, open up the bracket, and we need to update last to the current number. So we can say last equals nums square bracket k. Now we need to come right here, and we're going to say if flag, open up the brackets. So if the remaining array is strictly increasing, we're going to increment the count of the valid removals. So we're going to say ands plus equals 1. Now we need to return the total number of incremovable subarrays still. So we could just come down here and we could say return ands. Now that should be all she wrote, y'all. Let's go ahead and give it a run. See what happens. Oh, okay, so let's see. We got an error. That should be nums, not num. Sorry about that, y'all. Let's run it again. See what happens this time. And it's accepted, y'all. Look at that. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, let's see. Ooh, 4 milliseconds speeds, 50% of users. We definitely can get those numbers up, but right now we're just worried about being able to solve the problem that was presented to us. And I feel like this is a good solution for, excuse me. I feel like this is a good solution for that. It's a solution we all can learn from and use the knowledge that we've gained from this solution on future solutions. So that's why I picked it. Now, with that being said, y'all, make sure you get one more look at the code. One more look at the code. That's the top part. That's the rest of it. Read it, learn it, love it. And yeah, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.